Let's solve a couple of equations with logs. And in the homework, they say use the law of logarithms, which I don't even see that phrase used in the book. And then they say use change of base. So here's what I think they're getting at. So in other words, here's a equation, an exponential equation, 5x equals 8. And in the homework, they say first use the law of logarithms. Now we're going to solve this equation two different ways. And I think what they mean by the law of logarithms, I think they mean you take the log of both sides of this equation. Log base 10 or log or natural log. You can use either one. And maybe for this first problem, I'll do natural log. So if you remember, you can take the log of both sides of the equation. And now you remember our special rule about when you have an exponent inside the log, that the exponent, we can move out and it becomes a coefficient in front of the log. And that becomes very handy because that gives us a way to get that exponent, to get the x out of the exponent and into a place where we can actually solve for it. Because I can now solve for this x if I divide both sides by log 5. And I simply have log 5 over log 8 divided by log 5. Now in a minute, I'm going to grab my calculator and actually figure out what this is, what it equals as a number. But let me stop for now and let me just show you that it doesn't really matter, that I can also take this same equation and instead of using common log or log base 10, I could have used natural log. So natural log of both sides, natural log of 5x, natural log of 8. The same rule applies, the x can come down. So you have x equals natural log of 8 over natural log of 5. And in a few minutes, I'm going to actually calculate both of these, and we should see that they actually give us the same answer. So the bottom line is, it doesn't matter which kind of log you use. You can use log base 10 or natural log. But the key is, it needs to be one of those two, and that's because at some point, we're going to need to go to our calculator and actually figure out, like for up here, I'm going to go to my calculator and I'm going to need to figure out what the log base 10 of 8 is and what the log base 10 of 5 is. My calculator can tell me those. So my calculator can do this calculation. And in the same way, my calculator can tell me natural log of 8 and natural log of 5. So that's why we choose log base 10 or natural log, because those are the ones that our calculators are built to handle. All the rest of logs, most calculators can't do them. So this is almost like the first way to solve this, what they call the law of logarithms. The second way, I believe, they call this using the change of base rule. So here's my problem again. And now this time I look and I notice that my exponent is 5 to the x. 5 is my base, x is the exponent. And I remember that special rule that says, you know what? If I take log base 5 of 5 to the x, well, let me just show you what happens. I'm going to take log base 5 of both sides. Because log base 5 of 5x, the left-hand side just equals x. So that is a very quick and easy way to solve for x. The only downside is I'm left with log base 5 of 8. I cannot go to my calculator and figure out the log base 5 of 8. So this is where the change of base comes in. And I can do the change of base. And once again, when I'm going to do change of base, I can choose my new log. The base of my new log. We're going to choose either log base 10 or natural log. I'll just choose log base 10. So I'm going to go from log base 5, and I can say this is equal to log base 10 of 8 over log base 10 of 5. So the 8 goes up here, and the 5 goes down here, and this is simply applying this change of base rule. Now what's interesting is if I look, I'm saying x equals log 8 over log 5, and I go way back to the top. That's the same thing I was able to get with the first way, and then we're going to see in a minute it should equal this. So that's two ways. I think this one they call the law of logarithms, where you take the log of both sides, log base 10 or natural log. And this one they like to call the change of base. But the bottom line is you end up with the same thing. So just to finish this out, if I go to my calculator and I want to actually see what number log 10 base 8 is, and over log base 5. So my calculator, I can hit 8 and hit my log key, divided by 5, hit my log key and hit enter, and I get 1.292. I'll go to 3 digits. Now, just out of interest, if I do this natural log, I should get the same answer. So I go 8, and then on my calculator is an ln key, natural log, divided by 5 natural log equals 1.292. So those are the two different ways I think they want you to do it in the homework. Let's do one more quick problem like that, where you start out with an exponential equation. How about 3 to the 4 minus x equals 5. If I were to do it two different ways, how about I just take log base 10 on both sides. The 4 minus x, I can move down front, so now I have 4 minus x times log base 10 of 3 equals log base 10 of 5. Now if I were to solve this thing for x, I need to multiply out the parentheses. 4 log 3 minus x log 3 equals log 5. I'm going to get the x by itself. I'm going to move it to the right, subtract log 5. Equals x log 3. And now, if I want to solve for x, I can divide both sides by log 3. 4 log 3 minus log 5 over log 3. I can actually simplify this to 4 minus log 5 over log 3. Now just out of interest, let's see what happens if we try and use the change of base method. So let's write down my original problem again. So now since I have 3 to the 4 minus x, I'm going to take the log base 3 of both sides. Now log base 3 of 3 to the 4 minus x just equals 4 minus x. And here I have log base 3 of 5. Now if I want to solve for x, I'll just subtract, move the log to the left side, move the x to the right side. 4 minus log base 3 of 5 equals x. And now I need to do change of base for this log base 3 of 5. So I'll do log base 10 of 5 over log base 10 of 3. And you notice that's the same thing that I got here. So once again, two different ways. You'll get the same result. And just if I want to actually calculate a number, I'll take 5 and the log divided by 3 and the log equals. I'm going to subtract that from 4. This is 2.535. All right, so that's a way that we can use to solve some of these exponential equations.